Let's create a new Spring Starter project. We can see the project configuration window. Next, we'll configure our project metadata. Let's name our project Demo. We'll select Maven as our project type. Let's continue to the next step. Next, we'll add the dependencies our project needs. Great. Now we need to add the dependencies our project will need. Let's start by searching for Spring Web. I'll expand the web category to see our options. Let's add Spring Web. This gives us everything we need to build REST APIs and web applications. Let me clear this search field. Next, I'll search for the H2 database. Let's add H2 database. This is an in-memory database that's for development and testing. I'll clear the search again for our next dependency. Let's search for JPA, and we'll add Spring Data JPA. This provides powerful data access capabilities and makes working with databases much easier. Excellent! We've added all the essential dependencies. Now we can finalize and generate our project. Let's proceed to the next step. Let's finish creating our project. Great! The system is now generating our Spring Boot project and setting up all the necessary files. You can see it's importing the getting started content and initializing the language server to provide us with proper code assistance. Excellent! Our project is ready. Now let's explore what Spring Boot has generated for us. Let's open the pom.xml file to see what Maven dependencies were added. Let's scroll through the file to examine the project configuration. This pom.xml file contains all the Maven project metadata, including the Spring Boot starter dependencies we selected earlier, which handle web functionality, testing frameworks, and other essential components for our application. Let's look at the application properties file. Let's expand the src, so main resources directory. Let's open the application.properties file. Next up, we'll take a look at the main application class. Let's expand the src/main Java directory. Let's expand the com.example.demo package. And let's open the demo application Java file. We can see the main application class. Next up, we'll start building our REST controller. Let's right click on the src main Java directory to create our controller package. I'll select new and then package from the context menu. I'll type com.example.demo.controller as our package name. This follows Java naming conventions where we organize our controller classes in a dedicated controller package. And let's finish creating the package. We can create our Hello Controller class in this new package. Let's create our controller class by right-clicking on the controller package. We'll select new and then class to create a new Java class. Let's name our class Hello Controller. This follows the common naming convention for Spring controllers. Let's finish creating the class. Great! Our Hello Controller class has been created and is now open in the editor. Next, we'll implement the hello method and add the necessary annotations to make this a proper REST endpoint. Let's create our hello method with a public string return type. I'll add a return statement that sends back a simple greeting message. We need to add the proper annotations to make this a REST endpoint. Let's add the REST controller annotation above our class definition. Let's import the REST controller from the Spring Web package. Next, we'll add the get mapping annotation above our hello method.
Let's add the endpoint path by typing hello within the @getMapping annotation. Great. Now we need to import the required annotation for our endpoint to work properly. You'll notice there's an error with the getMapping annotation. It says it cannot be resolved to a type. Let's fix this by importing the required annotation from the Spring framework. Let's save our code changes. Let's save our changes. Great. Our endpoint is now ready. Next, we'll run the application and see what happens. Let's select our demo application.java file. I'll right-click to open the context menu. Let's hover over the Run As option, and we'll select Spring Boot app to run our application. Let's see what happens when we try to start our application. As you can see, our application failed to start because port 8080 is already in use by another service. This is a common issue when you have Apache Tomcat or another web server running on the same port. Let's resolve this port conflict by stopping the Apache Tomcat service. First, let's minimize our IDE to access the system files. We'll open this PC to navigate to our Tomcat installation. Let's access the local disk C drive. We need to go into the Program Files folder. Let's scroll down and find the Apache Software Foundation folder. We'll open the Tomcat 9.0 directory. Finally, let's access the bin folder where the Tomcat service controls are located. Now that we're in the Tomcat bin directory, we can stop the Apache Tomcat service that's causing our port conflict. Let's right-click on the Tomcat 9w.exe application. I'll click the Stop button to stop the Apache Tomcat service. The Service Manager is now processing the stop request for Apache Tomcat. Great. Let's click OK to close this window. Excellent. With Tomcat stopped, we can now reconfigure our Spring Boot application to run on a different port. Let's switch back to our Spring Tool Suite. We need to open the application properties file. Here, I'll configure a different port by typing server. It's port 8081. This tells Spring Boot to use port 8081 instead of the default port 8080, which resolves our port conflict. Let's save these changes. Now that we've configured a new port, let's rerun our Spring Boot application. Let's run our Spring Boot application again. We'll go to Run As and select Spring Boot App. Let's see if our application starts up successfully this time. Our Spring Boot application is now starting up successfully on port 8081. And you can see all the startup logs confirming everything is working properly. Now that our application is running, let's test our endpoint in a web browser to see it in action. Let's minimize our IDE for now and open up our web browser. I'll type the URL for our endpoint. That's http://localhost 808. Hello. Let's hit enter to access our endpoint. Let's verify what response we get on the web page. The browser displays our message, Hello Spring Boot. Let me highlight this text to show you clearly that our endpoint is working correctly. Great. Now, let's close the browser. Awesome. Our endpoint is working live in the browser. Now, let's test it with Postman to see how it performs with API testing tools. Let's launch Postman from our desktop. I need to sign in since the session has expired. Postman will open a browser window for authentication. I'll sign in using GitHub for convenience. I need to authorize Postman to access my GitHub account. Let's open Postman to complete the authentication. Great. Now that we're signed in, let's create a new HTTP request to test our endpoint. Let's create a new request. We'll select HTTP request type. We can send our request and verify the response. Let's paste our endpoint URL into the request field. Let's send the request. We can see our Hello Spring Boot response in the body section. Awesome. We've successfully created, deployed, and tested our Spring Boot endpoint using both a web browser and Postman. You now have a solid foundation for building REST APIs with Spring Boot.